Okay guys, what we're going to talk about tonight is going to be prime factorization. Okay, prime factorization. Prime factorization. So make sure whatever I write down on my notes, you're also copying down. Okay, prime factorization is simply when we take a number and we break it down into all its prime factors. So let's define prime. Okay, what is a prime number? Okay, what is a prime number? Well, a prime number can only be divided, can only be divided by itself and 1. Okay, a prime number can only be divided by itself and 1. So let's write some examples down of prime numbers. Well, let's think. The number 2, would that be a prime number? What are the factors of 2? Okay, well, the only factors of 2 are 1 and 2. So, does this fall under the category it can only be divided by itself and 1? Yes, so 2 would be a prime number. What about 3? Well, what are the factors of 3? What numbers multiply together to get 3? 1 and 3. Well, can 3 only be divided by itself and 1? Yep, so 3 would be a prime number. What about 4? So I'm going to put over here not prime. So not a prime number, okay? Not a prime number. Let's list some examples. Well, 4, the factors of 4 are 1, 2, and 4, okay? So 4 is not prime because it can be divided by 2 also. It's not only just itself and 1 like all these over here. Okay, so 4, the factors of 4 are 1, 2, and 4. So 4 is not prime. What about 5? 5 can only be broken down into 1 and 5. So yes, 5 is prime. Okay, what about 6? Well, the factors of 6 are 1, 2, 3, and 6. So 6 is not prime because it has factors other than itself and 1, 2, and 3. 7 would be a prime number. Can only be divided by itself and 1. Okay, the factors of 7 are only 1 in itself. 8 is not. 8, you've got 1, 2, 4, and 8. 9, let's think about 9. Where would you put 9? Not prime or prime? 9 is not prime. The factors of 9 are 1, 3, and 9. Remember, 3 times 3 is 9. So 9 is not prime. 10 is not prime. You've got 1, 2, 5, and 10. Okay, you get where I'm going here? 11 would be prime because 11 is only 1 in itself. So prime numbers, our only factors are 1 and itself. Okay, not prime numbers have factors other than 1 in itself, such as 1, 2, 3, and 6. Okay, so now let's figure out how to find the prime factorization of a number. All right, to do that, we're going to make what we call a factor tree. That's why you have a tree on your paper here. Okay, just to help you remember, prime factorization makes factor trees. All right, so what you're going to do is we're going to do some examples. All right, I'm going to do some examples up here. Before we do examples, let's come down here to the bottom and let's see what we call standard notation. Standard notation, okay? For instance, 2 times 2 times 2 times 2 times 2. That's standard notation, okay? It's written out. If I wanted to write this in exponential notation, simply meaning with an exponent, if I wanted to write the standard form using an exponent, Well, I would look at this and I would say, okay, what's my base? Okay, my base is basically what's the number I'm multiplying each time? Well, what number am I multiplying each time up here? 2. Okay, so 2 is my base. Okay, then I need an exponent. An exponent is a small little number that goes up top here. The exponent tells me how many times to multiply the 2 repeatedly. So how many times did I multiply the 2? Well, let's count. 1, 2, 3, 4, 5. I multiplied it 5 times. Okay, so there's my exponent. So my base is my big number. My little number is called my exponent. The base is the number I multiply repeatedly. Okay, so this is the number you multiply repeatedly. Okay, the exponent tells me how many times to multiply. Okay, it tells me how many times to multiply. So here's standard notation. 2 times 2 times 2 times 2 times 2. To write that in exponential notation, we need to figure out what's my base. What's the number I'm multiplying over and over again or repeatedly? 2. So 2 is my big number, my base. Okay, you can remember big and base, they both start with a B. Okay, your exponent is what you have to figure out next. Okay, the exponent is how many times did we multiply it? 1, 2, 3, 4, 5. So my exponent would be 5. All right, so that's how you go from standard notation to exponential notation. And you're going to need to know this when we do our prime factorization and make our factor trees. Before we do that, I want to practice some over here. Okay, so here's some examples. Here's some examples. If I gave you 4 times 4 times 4 times 4, that's your standard notation. I want you to write it in exponential notation. So you need a base and an exponent. Remember, your base or your big number is what you are multiplying over and over. So what are you multiplying? 4. Your exponent or your little number is how many times you multiplied it. So 1, 2, 3, 4. 4 to the 4th. Okay, well, let's solve this. 4 times 4 is 16. 16 times 4 is 64. And 64 times 4, well, shoot, I don't know that off the top of my head. It's 256. So 4 to the 4th power, or 4 to the power of 4, is 256. Now, please don't get confused and say, oh, that's 4 times 4. Well, what is 4 times 4? 16. That is not the same as 256. So be careful. When you're looking at this, it is not 4 times 4. Okay, it's multiply 4 repeatedly 4 times. 1, 2, 3, 4. 4 times 4 is 16. 16 times 4 is 64. And 64 times 4 is 256. Okay, so let's be careful on that. Let's do another example. If I wanted you to solve 5 to the 3rd power, we also say this is 5 cubed. Okay, well, what would that look like in standard notation, all written out? Well, that would be 5 times 5 times 5. This is the number I'm multiplying repeat. Okay, so again, 5 cubed, that's 5 times 5 times 5. The base is the number you're multiplying repeatedly. The exponent tells you how many times to multiply it. So let's see, 5 times 5 is 25, and 25 times 5 is 125. Okay, let's do one more example. Let's do 2. Okay, 2 to the 4th power. 2 to the 4th power. Well, the base is the number I'm multiplying, and the exponent, the small number, is how many times I multiply it. So 2 times 2 times 2 times 2. Well, 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. Okay? As you can see, if you looked at it and you were like 5 cubed, oh, 5 times 3. Well, 5 times 3 is 15. 15 is not 125. Same thing here. 2 to the 4th power. Well, you can't say 2 times 4 because 2 times 4 is 8, and that's not the right answer. The right answer is 16. So please don't look at it that way. All right, so now that we've dealt with standard notation and exponential notation, let's come up here and let's practice our prime factorization, making factor trees. So how we're going to do that is we're going to start out with a number, okay? We're going to start out with the number 180. I need to find the prime factorization of 180, so that means I need to get down to all prime numbers. Factors that are only prime numbers. So the way we're going to do that is we're going to make 2 branches. Okay, and we have to think to ourselves, what are 2 numbers that multiply together to get 180? Now guys, it can be any 2 numbers. It does not matter as long as both of these numbers that we pick multiply together to get 180. I'm going to choose 2 times 90. You could choose 10 times 18. Again, it does not matter as long as whatever numbers you pick multiply together to get 180. Now, my branches, 2 times 90. Okay, yes, they get 180, so we're good there. Now, I got to figure out, are either of these numbers prime? Remember, a prime number can only be divided by itself in 1. Ooh, well, 2 is prime. 2 can only be divided by itself in 1, so since it's prime, I'm going to circle it. Once I circle a number, I can stop with that branch, so I don't need to break down 2 anymore. 90, is 90 a prime number? No, it's not. So I got to think, what 2 numbers multiply together to get 90? Well, I know, 9 times 10. Is 9 a prime number? Nope. Is 10 a prime number? Nope. So I'm going to need to break these down. What 2 numbers multiply together to get 9? 3 times 3. Okay, 3 times 3. Well, is 3 a prime number? Yep. So I'm going to circle them. Now that I've circled them, I can stop. I'm going to go back to my other branch, 10. What 2 numbers multiply together to get 10? 2 and 5. Is 2 a prime number? Yes. Is 5 a prime number? Yes. Do I have any other branches that I can break down, or is all I have left prime numbers? All I have left is prime numbers. All my numbers on the bottom of my branches are circled, they're prime. So once I've done this, I can stop. Okay? Now I'm going to write this out in standard notation, written all the way out. So we're going to start with our smallest number, smallest prime number we have circled, that's 2. So I've got 2. And I'm going to cross these off after I use each one. Times 2. I've used all my 2s, so now let's do our 3s. Times 3, times 3, times 5. Okay, now that I've written out my standard notation, I need to write this in exponential notation, so using exponents. All right, so I'm going to look here. 2 times 2. Well, 2 times 2 is the same thing as saying 2 squared. Okay. 3 times 3 is the same thing as saying 3 squared. And then I have a 5. So this is the prime factorization of 180. So what I want you to do is make your factor tree. Get down to all prime numbers, all circled numbers. Then I want you to write it in standard notation. Okay. And then exponential notation. Exponential notation will be your answer. This standard notation helps you get to exponential notation, but this is your final answer. Let's do some more. Let's do like 2 more practice problems. Let's try 84. Well, what 2 numbers multiply together to get 84? Well, off the top of my head, I can think of 2 and 42. I know 2 is a prime number, so I'm going to circle it. Now let's go to 42. 42 is not prime. I know I can break that down into 7 and 6. 7 times 6 gets me 42. So is 7 a prime number? It sure is, so I'm going to circle it. What about 6? Nope. I can break that down into 3 and 2. Is 3 a prime number? Yep. And we know 2 is a prime number. So now that I've broken down all my branches into prime numbers, my bottom numbers are all circled. Okay, they're all prime numbers. I'm going to write my standard notation. Start with your smallest number. 2 times 2 times 3 times 7. So now that I have my standard notation, now I'm going to write it in exponential notation. So 2 times 2 is 2 squared times 3 times 7. There's my final answer. So the prime factorization of 84 is 2 squared times 3 times 7. Let's do one more example. How about 16? Let's break 16 down. Find the prime factorization of 16. Well, 2 numbers that multiply together to get 16, off the top of my head, I think 4 times 4. Again, it does not matter what numbers you choose as long as they always multiply together to get the number above it. 4 is not a prime number, so I'm going to break that down into 2 times 2. We know 2 is prime, so let's circle those. Same thing with this 4, that can be broken down into 2 times 2. Now that I've broken 16 down into all prime numbers, okay, I'm going to write my standard notation. So 2 times 2 times 2 times 2. Now let's write that in exponential notation. So my base is going to be 2, and how many times am I multiplying it? 1, 2, 3, 4. So my exponent is 4. So the prime factorization of 16 is 2 to the 4th power, or 2 to the power of 4, however you want to say it. And those are our notes on prime factorization. Make sure you have everything copied down on this that I did.